In this video, I will discuss the SQL EXPLAIN command and provide a high-level overview of its output. When a query is submitted to a Starburst cluster, the coordinator node of the cluster generates a query plan. The query plan breaks down the work needed to complete the query into pieces and estimates the amount of cluster resources each piece of work will need. It can be helpful for Starburst users to examine the query plan to troubleshoot why a particular query is running more slowly than desired, not producing the expected results, or even failing altogether. It is also useful to provide the query plan when seeking help with an issue from an administrator or through the community. You can generate and view the plan for a query using the explain command. Running the explain command does not actually execute the query, it only generates and displays the query plan. This means that explain is always safe to use, even with queries that are complex, resource-intensive, or failing to run. The explain command has several different options for generating and formatting its output. In this video, we will explore the distributed type, which is the default output option. Let's take a look at this in action. Here I am in the query editor for my Galaxy account, and I'm going to use explain to generate the distributed query plan for a pretty simple query. You can see I've set my catalog to be MySQL and my schema to be query plan without stats, which means that I only have to identify the table in my query. So let's hit the Run button, and you see we quickly get our results below, the results being our query plan. Notice that I can copy the query plan to my clipboard, which makes it easier to share the contents with someone else. I can also go to full screen view, which is what I'll do now. Let's take a closer look at the major components of the query plan. This query plan has only one fragment, fragment 0. Fragments are stages of work that will be distributed to Starburst worker nodes in order to complete the query. A fragment may be executed on one worker or multiple workers in parallel. Query plans are read from the bottom to the top. In this case, again, we only have one fragment, but if there were more, they would be numbered up from 0, and the highest numbered fragment would be executed first. Fragment 0 is tagged source, which means that it is reading directly from a data source. It includes one operation, a table scan, which in this example is reading data from the queryplanwithoutstats.customer table in my MySQL catalog. In more complex queries, there may be more than one operation in a fragment. Each operation in a fragment includes the layout and estimates lines. The layout line tells you the data structure that this operation is working on, including the columns and data types. The estimates line gives estimates of the resources that will be used to complete the operation. In general, operations that use less resources will run more quickly. Fragment 0 is tagged single, meaning that it will be executed on a single worker. This fragment also represents the work of streaming the data it read back to the Starburst coordinator node. Let's generate the distributed query plan for a second query, this time asking for specific columns from the customers table. One of the great things about Galaxy is that we can run multiple queries in the same tab. This will make it easier for me to compare results. So in our first query plan, the engine estimated that it would need about 43 megabytes of CPU. Let's look at the second query plan. And this time, it's only estimating about 9 megabytes, a significantly smaller number. Can you guess why the second query would require less CPU? If you said because we're identifying the columns we want to retrieve, you're correct. This is called projection, and it's always better to do this when you can, because it reduces the amount of data that needs to be pulled by the engine. Okay, let's look at the query plan for one more query. This one has a join in it, so the query plan should be a bit more complex. This time I have two fragments, 0 and 1. Remember, we're reading the query plan from the bottom up, so we'll start with fragment 1. This plan involves a join, so Starburst will need to read more than one data source and join the results together, then stream the results to the client. Take a look at the estimates line for the scan project operation in fragment 1. This operation includes two actions, a scan action, which reads the rows of a table, and a project action, which reads the columns. The estimates line shows the estimated resources each action will take separately, using a / to separate them. We can see that the scan project operation in this fragment is reading from the MySQL table. Moving up to fragment 0, we see a scan filter project operation that is reading from the PostgreSQL table. The operation to join the data comes directly after. That's all for this video. If you're completing the course Exploring Query Plans, then you have access to the data that I used. I encourage you to generate your own query plans, read through them, and jot down any questions you have. As you work through the course, you'll learn more about the elements that weren't covered in this video. Thanks for watching.